I got nothing.
Mark, look.
Well, yours is turning color.
Because you're just not using enough carbon dioxide. Look at that. Keep going. You're pretty close. You're like 10 more seconds. No more than like 30 seconds. No, you're good. Look at that right now. See? Look. Ta-da. What are you in? Look at you. Ta-da. All right. So this was...
Is that good?
Well, this just is an indication of carbon dioxide.
Oh.
It would have been a whole lot easier if we would have done this, because what we had inside was an indicator. It's called phenolphthalein, and a little bit of a base. Put on your gloves.
Oh, okay.
And believe it or not, it was the carbon dioxide in our breath. It has nothing to do with your breath. You know, it's just carbon dioxide. Get a piece of dry ice. If you would have just put a piece of dry ice in there, it would have happened a lot faster. Here, watch this. Notice how it goes down. We're generating carbon dioxide gas. That carbon dioxide gas is an acid.
Oh, my gosh.
Isn't that amazing? So it's a nice little change. So see, it would have been so much faster with just a little chunk of carbon dioxide. Hey, let's show people at home how they can make their own indicator. Years ago, you could take X-Lax tablets and grind them up, and you would make that pink stuff if you put it in a little bit of alcohol with a base. So let's move this off to the side, and I'll show you how we're going to do it. So it's time for our little cooking segment. All right? So what you're going to need is some red cabbage juice.
Of course.
Because there is a chemical inside that red cabbage leaf that is just a wonderful dye. Got it?
Yeah.
So this goes down inside here like this.
Okay.
Okay, and now this goes on top, and now you just kind of grind it. Again, compelling television.
This is like a Saturday Night Live skit, you know that?
It's blending.
Will it blend?
There you go. All right, so there you go. So believe it or not, that's it. Now the whole studio is going to smell so pretty for the next 3 hours of news. All right, so here's what's going to happen. Now we strain it out, and this is our indicator. So believe it or not, that purple juice right there is a beautiful acid-base indicator. So that's all we need. So if you'll bring over the little graduated cylinder, let's use the brand new one here.
Okay.
Yeah.
All right.
So now take a look at this. Let me fill it up. So here's our indicator. So this is showing kind of a pH of 7. So that's just in the very middle. It's water. If we were to add a base to it, look at this.
A little ammonia?
A little ammonia goes inside. So here's a little bit of a base. Notice the color change that we get here. Look at this.
Green.
We do. So watch this as you stir.
Oh, look at that.
Isn't that absolutely gorgeous?
Who knew that there was so much chemistry in bad breath?
See, it was just the hook to get you in. So this is green if it's a base. And if we trip it back with vinegar and it's an acid, watch it kind of come back this way. It's just a real kind of pretty reaction that's there. Isn't that kind of fun? So as you stir it, so just using cabbage.
Acids and bases are everywhere. They're used to make foods, soaps and detergents, fertilizers, explosives, dyes, plastics, pesticides, even paper. Our stomachs are very acidic. Our blood is slightly basic. Our proteins are made up of amino acids, and the letters in our genetic code, those A's, T's, C's, and G's, are all bases. You were probably taught how acids and bases behave on the molecular level. You were probably never taught that a long time ago, like ancient Greek ago, before anyone knew about atoms or molecules, acids and bases were defined by how they behaved. Acids tasted sour and corroded metals. Bases felt slippery and could somehow counteract.
Without you realizing. So let's see. One more quick thing to look at. Oh, let's look at two more things. This is pretty cool. We can actually tell the difference between different acids and alkalis by using various types of indicators. And we're going to play around with this in class. But this is the most famous one, the universal indicator in the pH scale. There's basically a liquid which can be used as a liquid, or it can be soaked in filter paper, and we basically pull it out like strips of paper that contain various chemicals that will react differently based on if they come into contact with acids or alkalis. And it turns out that if you dip a little bit of that paper into something that's acidic towards this end, then you tend to get red and orange colors. If you dip it into an unknown liquid and it turns out to be blue or purple, that tells you that it's going to be strongly alkaline. And there is something that's right in the middle, and that's called neutral. So the scale usually goes from 0 to 14, and 7 right in the middle is neutral. So pure water is actually neutral. So if you're drinking bottled water and you test it out, it's often going to be around this pH 7 range. Our saliva is in this range as well too. we talked about before, if the stomach contents actually contain acid, if we were to actually test out our stomach acid, we would find our stomach acid is pretty strong. We're going to talk more about that later. Okay? And so what you can do with all those household substances is you can actually test it with this pH paper and then find out if that substance is actually acidic or alkaline. You can use it in liquid form as well too. So you see this teacher here has created a test tube, a measuring cylinder filled with different substances that's probably spreading out and it's causing various pHs to show up. Okay, we call this the pH scale as well too, and we're going to be learning more about that in class. So we call this material, the stuff that's here is either universal indicator paper or universal indicator solution, and we call the scale running from 0 to 14 the pH scale.
I'm going to give you a quick little lesson on acids and bases. So I just have some water inside. We're on a magnetic stir, so we can kind of mix it around. You remember that we've used cabbage juice in the past. So you take a cabbage leaf and you boil it and you extract the cabbage juice. Right. This is similar to that. It's called a universal indicator. It's the same thing that a chemistry teacher would use. So this particular indicator will change if there's an acid or a base. So for example, if I squeeze in a little of an acid, watch the color change that you see there. See how it changes color? Yeah. Cool. So it goes red when it's an acid, and it turns back to blue when it's base, a little bit darker blue. So we can kind of take it back that way, so it's kind of greenish blue that
Chemistry.
way. Is that kind of fun? Chemistry in action,
is.
all right?
Yes.
So here's what we're going to do is to that pot, I'm going to add some milk of magnesia, all right? It's actually called magnesium hydroxide. So this is going to go inside. So here's our milk of magnesia. So this is exactly what this stuff does in your stomach, is it's going to help neutralize your stomach.
And neutralizes the acid, right?
So let's simulate the acid going into your stomach, or stomach acids. So this is a little bit of vinegar, so I'm just using vinegar. Okay. All right, so in the pot, water and a little of the indicator and the milk of magnesia. Watch what happens. We're going to add some. So watch what happens to your stomach. It turns acidic, but now watch what the milk of magnesia does. It starts to work, and as it starts to work, you start to see those color changes, and that's what milk of magnesia does. So that magnesium hydroxide gets used up, and so now it's neutralizing your stomach.
Does it work that fast in your stomach?
I don't know. I mean, in the demonstration, so you can see it right away. I don't know. We'll have to look at that and ask the doctors. But isn't that amazing?
It's just potent, isn't it?
It is. And we're using up that magnesium hydroxide right now, but I think it's a great way to be able to show kids what an antacid is all about. It really tries to neutralize your stomach. See how it just keeps on taking it back?
That is very cool. Ooh, that is a great school science explainer.
Isn't that a great one?
That is
and
a good one.
for a science fair project, you just simply test the different antacids and see how fast they go back.
And they can get these these are commercially available chemicals.
So we're just using cabbage juice indicator, milk of magnesia, and you could use a little bit of vinegar, and you've got it.